Hello and welcome to another video in the series covering data structures. We've already talked about lists and stacks, and today we're going to have a look at queues. Since we're going to implement a queue as a modification of a list, in case you're not feeling comfortable using lists, I highly recommend that you watch that video first. Now, what is a queue? Imagine you're in a supermarket. You've finished shopping and now you want to pay for your groceries. You go to the till and there's likely to be a few other customers already forming a queue by the conveyor belt. The conveyor belt only moves in the direction marked in the picture, so the front of the queue is on the left and the last customer is on the right. Now, if you think back to how lists worked, one end of a list, the one containing the first element, was called the head. The other end, containing the last element, was called the tail. Let's say the customers in the queue are elements of a list. The one whose groceries are now being scanned is at the head of the list, and you, as the one joining the queue, will stand in the tail of the queue. And assuming everyone's cultured and polite, the customers will all be served in the order they joined the queue. Similarly, if you place your groceries on the belt in a specific order, they will likely be scanned in this order. And that's what queues are used for in code. They let us store a bunch of elements in the original order and make sure that the elements are served in the same order. So let's have a look at code. In modern languages, you may see something like this. Queues come built in standard libraries, wrapped in wonderful mechanisms that let you use them with different types of data. We're going to focus on how queues work, so our implementation will be simplified and will only store string elements. We'll create a queue like this, and of course, we'll have some methods available for working on the queue. The first method, for adding items to the end of the queue, is commonly called enqueue, and the second method, for retrieving items from the front of the queue, is commonly called dequeue. If you remember how lists looked, we had a chain of elements with single connections between them. We called the first element the head of the list, and the last one the tail. The principle is the same here, but for better readability, we're going to call the first element on top of the list first, and the last one last. The class for individual elements in the queue, we'll call it a queue node, is essentially the same as one we had in a list. We're going to store a string name and a link to the next element in the queue. The main queue class is going to keep references to the first and last elements, as well as the two methods, enqueue for adding elements to the end of the queue, and dequeue for removing items from the front of it. Let's start with implementing the enqueue method. First, let's create a new node to store the item being added in. Next, we have two options. If the queue is currently empty, and that is, if the first element is null, we want the new node to be at the front of the queue. But also, since there's only one element in the queue now, it's also the last one in the queue. If, on the other hand, the queue already contains elements, we add the new item after what used to be the last element until now. And we need to now update the last reference so that it links to the new node. This is the same algorithm that we used in the video covering lists, so in case you'd like a more detailed description, you can find it in there, the link's in the description below. Alright, so now that we know how to add items to a queue, let's implement a method for retrieving items from the front of the queue. First of all, we need to remember that the queue may be empty. If there are no elements to be retrieved, our job is done here and we return null. If there are elements in the queue, we copy the item at the front of the queue to a temporary variable. Then, we move the front of the queue forward by one element to whatever was after the first element. Also, if now after moving the front of the queue, it turns out there's nothing left, we need to remember to update the reference to the last element and set it to null. And finally, using the copy to what used to be at the front of the queue, we return the name of that item. And that's it, the entire implementation of a queue done and dusted. Now, you may remember that stacks followed a last in, first out rule. Queues, on the other hand, follow a first in, first out rule. So whoever gets to the queue first will also be served before others. And obviously, we have to finish the topic by talking about speed and space and efficiency. Both adding items to the queue and retrieving them are fast operations, and they don't depend on the number of items in the queue in any way. You always operate just on the tip of the queue, either the front or the end, ignoring all other items in the queue. And just like it was with stacks, searching for a specific item in a queue generally isn't an operation you'd find in standard implementations of a queue. Naturally, you can implement it. After all, it's just a list, and if you remember from the video covering lists, we did search for items in order to remove them from the list. However, it will require potentially searching for the entire queue just to find out the item you're looking for isn't there. And again, it breaks the main point of using queues, which is accessing items in the queue in the order they were added. And finally, in terms of space, in addition to the names of elements in the queue, we also need to use extra space to keep the connections between elements. Anyway, that's it for today. As always, if you have any questions or suggestions, feel free to leave them in the comments below. Next time in the series, we're going to talk about trees. And for now, thank you for watching and goodbye.